All right, so today we're taking a deep dive into computational problem solving, and we've got an awesome guide, Professor Barba.
Oh, yeah, she's amazing. Really a leading expert in this whole area.
And, this deep dive is really perfect for anyone who's just starting out with this whole computational problem solving thing. So if that's you, listener, you're in the right place.
For sure. And, one thing that really struck me right away was Professor Barba's little story about, where the name Python even comes from.
Oh, yeah, the Monty Python connection.
Yeah. Did you know about that before?
Honestly, nope. But it instantly made Python seem, I don't know, less scary.
Right, less intimidating.
Totally.
Mm-hmm.
And then she goes on to call Python a high productivity language.
Mm-hmm.
And that got me thinking, wait a minute, isn't Python supposed to be kind of slow?
Yeah, that's a common misconception, and Professor Barba addresses that head on. It's true that in terms of, pure processing speed, how fast the computer actually crunches the numbers, Python might not be the absolute fastest.
Okay, yeah.
But the key point she makes is that a programmer's time is way more valuable.
So it's more about how quickly you can get stuff done with the language, not just raw speed.
Exactly. And Python's designed to make you super efficient. The way it's written, it's really readable. And then there are all these incredible libraries, tons of pre-built tools.
So you don't have to reinvent the wheel every time.
Exactly.
Plus, she mentions how Python is used by all these big names like Google and Facebook.
Oh, yeah, that's a big one. If it's good enough for them.
Right. It must be pretty powerful.
Definitely. And, we can't forget about AI and machine learning.
Which are huge right now.
Enormous. And Python is the leading language for all that. So, learning Python, it's not just about some abstract skill. It's about being able to do super relevant stuff.
Absolutely. Okay, we know Python is awesome and used everywhere.
Yeah.
But where do we actually begin?
Well, Professor Barba starts us off with a classic, the hello world example.
Right.
Uses the print function.
Yeah, print hello world.
And boom, Python displays the text hello world right on the screen. So simple, but it's our first little conversation with Python.
Yeah, it is. It's like, hey, Python, nice to meet you.
Exactly. And this example, it also perfectly illustrates the idea of a function print, that's the function's name, and then the text hello world, that goes inside the parentheses. That's the input.
The thing we're giving to the function.
Yep. And functions, think of them like prepackaged actions, little bundles of code that Python already knows how to do.
So we don't have to write them out every time.
Exactly. We just tell Python which function to use and what to act on.
Okay, I like that. It's like giving Python a command with specific instructions.
Perfect analogy.
And then Professor Barba also shows us how to use Python as a calculator.
Yeah, unleashing that computational power.
I was really interested in the square root example. She does 9 to the power of 1/2. It reminded me that order of operations, that matters in programming too, just like in math.
Oh, absolutely. You can't forget about PEMDAS.
Right. Parentheses, exponents, multiplication and division, addition and subtraction.
Yep, that whole order. Python follows the same rules. So if you remember PEMDAS, you'll avoid a lot of headaches.
For sure. Okay, so then Professor Barba introduces this concept of variables, and she makes them sound so, I don't know, almost like they have personalities.
Well, they kind of do.
Right, like she talks about giving variables a name and a value, and she uses an equal sign to connect them.
It's important to remember, though, that equal sign, it's not quite the same as the one we use in, algebra class.
Oh, how so?
In programming, it's more like an arrow. It's saying, take this value and put it in this container with this name.
Okay, so it's not an equation, it's more like an instruction.
Exactly. We're telling Python, hey, create a container, call it message, and put hello world in it.
Got it. And then later on, we can use that variable's name to get back to the value.
Right. It's like a shortcut. Super useful.
So we said hello to Python, we've done some calculations, and now we've got these containers for storing information. What's next?
Well, then Professor Barba gets into this idea of adding strings, which is actually called concatenation.
Oh, yeah. It's not really adding numbers. It's more like putting words together.
Exactly. Like puzzle pieces fitting together.
I like that.
And this leads us to the whole concept of variable types in Python.
Oh, yeah. She talks about int, float, and stoy.
Right. And, at first I was kind of like, why do we need all these different types? Can't Python just figure it out? But it makes sense. Imagine you're trying to calculate the area of a circle, right? And you accidentally use a word instead of a number for the radius. Python would be totally lost.
Oh, yeah.
That's where these type labels come in. Int tells Python, hey, this is a whole number. Float means it's a number with decimals. And string means it's like a string of characters, like text.
So they're like little flags that help Python avoid making silly mistakes.
Precisely. And luckily, Python has this awesome feature called duck typing. Professor Barba explains it using a really fun analogy.
Oh yeah, the duck analogy. If it walks like a duck and quacks like a duck,
Python's going to treat it like a duck. It's like Python tries to figure out what type of variable you're using based on how you're using it.
Okay, so it's not always super strict about the labels.
Right. But if you ever need to double check, you can always use the type function.
Just to make sure.
Exactly. And then Professor Barba takes things a step further, showing us how to assign the result of a whole operation to a new variable.
Okay, yeah. Like, instead of just dealing with a number or a string directly, we can actually store the outcome of something more complex.
Exactly. It's like building with blocks. The output of one step can become the input for the
Not
next.
get fancy. So let's say we calculate the area of a circle. We can store that value in a new variable, call it area, and then use it later.
Right. And this opens up so many possibilities.
It's like creating these chains of commands where everything flows together.
Absolutely. And then to top it off, Professor Barba introduces us to these special variables. They're built right into Python. True, false, and none.
I remember being a little confused by those at first.
Yeah, they can seem kind of abstract, but they're super important.
So what are they exactly?
They're like special keywords. They have specific meanings in Python's logical system.
Okay, so they're not just random words. They actually represent these core concepts that Python uses to make decisions.
Precisely. And what's really interesting is how these special variables, they connect to this bool function that Professor Barber talks about.
Yeah, she describes it as a way to reveal the truth behind any Python object.
Right. It's like this, imagine you have a magic wand that can tell you if something is true or false in Python's world.
Okay.
That's basically what the bool function does. You give it anything, a number, a string, even those special variables we were just talking about, and it tells you, does this evaluate to true or false?
So it's like a truth detector for Python.
Yeah, exactly. Professor Barba gives some examples with numbers. If you put any number, except for 0, into the bool function, it'll spit back.
True. Because any number that's not 0, Python sees that as, truthy.
Right. But if you put in a 0, then it gives you false, because 0 is considered falsy.
It's like Python has its own little system for deciding what's true and false.
It does. And this whole idea of truthiness and falsiness, it's super important for what's called Boolean logic. It's all about working with these truth values, true or false.
Okay, and this is where those logical operators come in, right? The and not the Professor Barba mentioned.
You got it. Those logical operators, they let us build these more complex logical expressions by connecting simpler comparisons.
Okay, so can you give us an example?
Sure. So the AND operator, that one requires both conditions to be true for the whole thing to be true. It's a chain if one link breaks.
The whole thing falls apart.
But then with the OR operator, only one of the conditions needs to be true.
It's more flexible.
Way more. I'll take the bus or I'll walk. Only one of those has to happen for me to get where I'm going.
Gotcha.
And then there's not, which is basically like a reversal. It flips the truth value.
So if I say it's not raining, I'm basically saying the opposite of it's raining.
Exactly. If it is raining is true, then it's not raining is false, and vice versa.
I'm following you.
Good. And these logical operators, when you combine them with comparison operators, equal for equals, for not equals, for less than, for greater than.
Yeah, those are more familiar.
Right. So all of these together, they give us this incredible control over how our programs make decisions.
So we're not just telling Python what to do step by step. We're actually giving it the ability to think logically.
Yeah, exactly. We're giving it rules to follow so it can respond to different situations.
This is getting pretty deep.
It is. And Professor Barba, she actually gives an example of using these logical operators.
I remember that one. I have to admit, I got a little lost.
Yeah, they can be tricky at first. Logical expressions, it's all about breaking them down step by step.
Like a puzzle.
Exactly. Professor Barba's example, it shows how we can combine those comparison operators and the logical operators to, evaluate multiple conditions at once.
We've gone from hello world to calculating square roots to storing information in variables, and now we're building these complex logical expressions.
We're on a roll.
I know. It's been quite a journey.
And we're just getting started. This whole world of computational problem solving, it's huge, and it's always changing.
A little scary, but exciting too.
Definitely. But with these fundamental building blocks that we've talked about today, You're well on your way to tackling all sorts of cool challenges.
Wow, that was a lot to take in, but in a good way.
Right. We really covered some ground with Professor Barba today.
I feel like we've gotten this awesome crash course in computational thinking. And one thing that really stuck with me was Professor Barba's point about Python being a high productivity language.
Oh, yeah. That was a good one.
It's like a reminder that we don't have to get bogged down trying to write like the most perfect code ever.
Right. Sometimes just getting things done efficiently, that's the priority.
Exactly. And Python with its like clear syntax and all those
It
libraries.
was perfect for that, for like quickly prototyping and iterating, which is so important in science and engineering.
Plus, we learned that Python, it's not just for beginners either.
Oh, no, not at all.
Professor Barba mentioned how it's used by Google and Facebook.
Yeah, and for AI and machine learning, all that cutting edge stuff.
So learning Python, it's not just about, some basic skill.
Mm.
It's really about having this tool that can grow with you.
100%. As you learn more, as you get more ambitious, Python can keep up.
Another big takeaway for me was understanding those variable types.
Oh, yeah. Int, float, string.
At first, I thought they were just like a technical detail.
Right, easy to overlook.
But now I see how important they really are. It's like Python needs that information to understand how to process the data.
We got to use the right data types so Python doesn't get confused and like mess up the whole recipe.
And that's where that duck typing comes in, right? If it walks like a duck,
And quacks like a duck.
Python's going to treat it like a duck. It's like Python's pretty smart. It can often figure out the variable type based on how we're using it.
But if you're ever unsure, there's always the type function. Just double check.
Always good to have a safety net. So to our listener, now that you've taken this deep dive with us and Professor Barba,
What are you going to do with Python? What problem are you going to solve?
maybe you want to analyze data from an experiment or automate something that's really boring.
Or create a game? The possibilities are endless.
The important thing is to, just get started.
Experiment. Make mistakes. That's how we learn.
And Professor Barba's work is full of inspiration. So keep learning, keep exploring, and most importantly,
Have fun.